In this video, we're going to talk about sampling distributions. So the sampling distribution of a statistic, this is simply the distribution of all of the values of the statistic when all possible samples of the same size n are taken from the same population, right? So we could have all kinds of different sampling distributions. We could have a sampling distribution of the sample mean, where we're looking at all the different sample means. We could have a sampling distribution of sample variances, where we look at all those different sample variances. We could have a sampling distribution of sample proportion, where we have all those different sample proportions. All right, so we consider all samples of a particular size that could come from the population. All right, so let's think about an example. Let's look at an example. So suppose we have a three-sided die, or we have a six-sided die that just has the numbers 1, 2, and 3 on it. If we were to roll that die 2 times, and we wanted to think about what numbers could come up on the first and second roll, and what is the mean number that comes up. So we could get a 1 and then a 1, and so 1 plus 1 over 2 is 1. So we could get a mean of 1. We could have rolled a 1 first and then a 2 with the second roll. 1 plus 2 over 2 is 3 over 2, or 1.5. We could have rolled a 1 first and a 3 second. And so 1 plus 3 is 4 over 2 is 2. We could have rolled a 2 first and then a 1. If we add those together, we get 3, and we're taking the mean, and so we divide it by 2 because there were 2 rolls. We get 1.5. We could have rolled a 2 and then a 2, which would give us 4 over 2, or 2 as the mean. We could have rolled a 2 and then a 3, which would give us 5 over 2, or 2.5 as a mean. We could have rolled a 3 and then a 1, which would have given us 4 over 2, or 2. We could have rolled a 3 and then a 2, which if we add 3 and 2 together, we get 5 over 2, because there were 2 rolls again. We're finding the mean. Or we could have rolled a 3 and then a 3. We add them together, we get 6 over 2, or 3. The average, the mean roll is 3. So that describes all the different ways we could have rolled 2 three-sided die. And that is not the sampling distribution. So the sampling distribution, it would say, well, these are all the means that we could have had come out. We had 1, we had 1.5, we had 2, we had 2.5, and we had 3. Those were all the means that showed up. And the probability of a particular mean. So 1 showed up how many times? It showed up exactly 1 time out of 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of getting a mean of 1 is 1 out of 9. For 1.5, it happens 2 out of the 9 times. The 2, that showed up 3 times out of the 9, or 1/3. And then we have 2 out of the 9 for a mean of 2.5. And finally, that mean of 3, it shows up exactly once out of those 9 times. Notice if we add all those up, 1 plus 2 plus 3 plus 2 plus 1, all over 9, each individually over 9. When we add that up, we do get the sum of those probabilities is 1. And so 1/9 of the time we get a mean of 1, 2/9 of the time we get a mean of 1.5, 3/9 of the time we get a mean of 2, 2/9 of the time we get a mean of 2.5, and 1/9 of the time we get a mean of 3. All right, so there we went through and we considered all the possible things that could happen if we rolled a three-sided die twice. what happens if we roll a three-sided die 3 times? Well, let's take a look at that. So now we're going to roll a three-sided die 3 times. Here, there are now no longer just 9 things that could happen. There are actually now 27 different possible outcomes. And here I've gone ahead and went through and written out all of those possibilities with the means. And so if we want to write this sampling distribution, we'll say here is x bar. We're going to describe all of the means that could show up. So we could get 1, we could get 4/3, so 1 1/3. We could get 5/3, we could get 6/3, which is 2, 7/3, 8/3, and 9/3, which is 3. So each of those show up at some point in time. The probability of each of those means. So 1, that shows up exactly 1 time. It shows up right there. 1 out of those 27 different possible rolls of 3 die, of 3 three-sided die. We see 4/3 showing up 1, 2, 3 times for a mean of 4/3. So that's 3 out of 27, which is 1/9. We see 5/3 showing up as a mean. 1, 2, 3, 4, 5, 6. So 5/3 shows up 6 out of 27, or 2/9. That mean of 2, that shows up 1, 2, 3, 4, 5, 6, 7 times. 7 out of 27. And 7/3, that shows up 1, 2, 3, 4, 5, 6 times out of 27, or 2/9. 8/3, it shows up 3 times out of 27. And so 1, 2, 3 times out of 27. And 3 only shows up as a mean 1 time out of the 27. So that would be a sampling distribution for the sample means when we roll a die 3 times. So that's sampling distributions. In the next video, we'll look at a sampling distribution for something other than means, because we can talk about sampling distributions for other statistics, right? We could talk about sampling distributions for variances or for sample proportions. We could talk about sampling distributions for ranges, for any statistic that you might choose. We could think about how is that distributed among all the different samples. All right, we will talk to you in the next video.